new, but this is something that is becoming more common.
Volumetric video. It's also becoming, we have seen some prototypes and it's being used more and more. Light field video, it's still very early, and even if we have big companies that are moving on now, and it's still just demos. Real-time production and real-time post-production. I wanted to talk about those because those are coming more from the VFX industry, but I think they are very relevant for the VR industry as well. There are really interesting things going on there. So photogrammetry is basically the process of taking a bunch of 3D images, of 2D photos, sorry, 2D photos, going through some calibration and image processing in order to reconstruct a 3D model. And this is not something new. This has been done for decades now, and there are software that allow you to do this reconstruction. But that's not it. Once you have your high-resolution 3D model, you still need to convert it to a low-poly 3D model, but you use the high-res images that you have to still have it look like if it's a high-res model. And the reason to do that is because you want to integrate it into a game engine that has to do real-time renders, and therefore you need to be aware of your model not being too heavy, otherwise you won't be able to render it. So there are a lot of intermediate steps, and it's still sometimes faster than totally modeling from scratch and creating all the texture from scratch. It's not, it doesn't work. It works well with static environments. So if you have tree with leaves moving, it's not going to make it easy. Or if you have totally white surfaces, it's not going to work. It's a bit like stitching. You need to have a lot of details and overlap in order for that to work. You can see here an example of how many photos you need to take in order to make a 3D model of this trunk and rocks. So it's a few maybe 100 or different levels and a lot of overlap. This one, so this can be done, the first one I was showing you was like with a pine cone. This is a small object. This is kind of a medium-sized object. And now this can be done also with entire landscapes. And this one was done by taking photos from an helicopter. This was for Fast and Furious 6. This was not for VR. So we didn't care that much about the render times. But this is a full model, and then the rest of the movie was composited on top of this canyon, and this canyon was fully scanned, but then it was modified. It's like we never use something as it is in reality, There were houses and roads that were removed to make it look wide, and it was made deeper and wider and all kind of stuff. But the photogrammetry has been used, both for people building games and for people doing films for a long time. So the process, you can use reality capture, photoscan are the most used software. And, but there are a lot of other softwares that you need to use. 3D software, tech software to, bake the texture, then game engine. So it's not a simple workflow, but it is well used and understood. I want to show this video that shows kind of a quick summary of what it is, if it's going to work. Yeah, so you can see all the photos that are being taken all around. This one is a big ruin of a big building, cathedral. And then it's being reconstructed as a 3D model, as a point cloud, and then converted into a 3D model. And then here you got the final thing. And you can move through it, and it looks like really real. And so what photogrammetry allows you to do is to have full 6 degrees of freedom interaction and manipulation. When it's a smaller object, you can manipulate it. When it's a bigger object, it's mostly navigational. You can move through it. But there is a restriction. It's only still objects. You cannot have people, you know. You cannot have video, basically. So the next step is volumetric video. Volumetric video is sometimes called 4D. 4D means, you know, 3D plus time. So basically, you build something in 3D that moves over time. And it's mostly used to capture people, because that's what was, you know, is missing with photogrammetry. And we place the camera, when I say outside in, it's because the cameras are usually placed all around the person or sometimes just in front. And that's how you capture. So it's very different from a 360 camera, which is inside out. You know, you are centered and you capture everything around you. The early days of volumetric video claim, this was done mostly when the Kinect came out, and a lot of artists wanted to hack some ways, and this was the Eminem, part of an Eminem music video, what you see on moving on the left. There was a documentary, Clouds, that were really amazing. They were interviewing digital artists that were captured with an RGBD camera, which is RGB plus depth. And it was not all around. You could kind of, you know, look around, but not fully. And then at the same time, as they were talking, you could also see their interactive art being recreated. And it's a documentary that is available in VR as well. So this was like a much simpler way, you know, and cheap way of doing it, even if it was not perfect. And then more recently, you know, since 2015, basically there is like a plethora of smaller companies that have started to do volumetric. For example, Hyatt and Uncorporeal and DevKit. It's been used to incorporate live actors into documentaries, or even a fiction, Giant at the bottom, that was shown at Sundance, I believe, last year. For the last one, for 0 VR days, they used a camera from Intel that is designed for capturing depth as well as RGB. So something a bit more sophisticated than Kinect. But everyone is kind of doing their own sauce, you know. It's like there is specific proprietary format, proprietary compression, computing in the cloud where you can upload and it computes for you, and even like playback. It's custom. So nothing like as a simple, you know, workflow and the same formats that you could use. And more recently, you know, the bigger company like Microsoft and Intel have really gotten big on volumetric video capture. They have set up capture stage where you can come and capture live actors. And let me show you the Microsoft one. You might have seen it already. So you can see that, you know, they have this whole array of camera all around and very uniform lighting. And they have a way of calling them holograms. Also, they are not really holograms. They are really 3D models. But, you know, that's a name that resonates better maybe with the public. So basically, each one, it's the same, you know, they are outputting different things. With Microsoft, you get a 3D animated model in high or low polygons, and a file that you can input into your Unity or Unreal Engine. With Intel, it's a bit different, but at least everything that they do is open source, they say, so you can get their software and tweak it, which is a good news. Volumetric video, it's been integrated in a few projects. It's becoming more used. There is still a wide variety of, capture settings, resolution formats, no standards. It's full 6 degrees of, interaction, but there is still, you don't really interact with this character once it's been modeled in 3D. It's not like you can talk to it and it will answer you back or something. But that's, they feel definitely fully integrated with the environment. Then light field video, we've heard a lot about it. The idea was to be able to have a video, not a 3D model, where you can also move around and hopefully with the bigger camera move, several steps or just your head with some of the most recent cameras. I'm kind of running out of time, so I'm going to get through that quickly.
You actually have a little bit more time, about 10 more minutes.
Okay, thanks. So very early on, there was a demo at SIGGRAPH in 2014 where Auteuil presented one of their early demo. It was kind of a 3D image, but it was really yeah. So this is like just images. It's not a 3D model. It's nothing, and it's not stereo. This is, the type of stuff that light field video is going to give you. Is a full realistic world where it looks like you can really move around as if it was a 3D model. Auteuil has created their own kind of format and Orbix, and they have kind of been really advanced about that, and they partner with Facebook last year to use their technology with a new kind of camera. So instead of those big cameras that you see here that Lightro had developed and Google is kind of developing, they are focusing on a smaller camera. So and it's going to use only the depth map to be able to, have you move around and compute the missing pixels. So it's kind of more limited, but it's also more likely to come out as a product. And we don't know what the pipeline is. I mean, really, I looked for information. The only one that share their pipeline is Auteuil, and they have developed this specific format called Orbix, and they have plugins for different tools like Nuke and Unity and Unreal. And they have also a way of playing back those things. They call it the next generation video codec. It's still very heavy, but it's very promising. Another way that light field video has been used or light field is for CG render. So basically, instead of capturing with a huge camera reality, you can render the CG with multiple cameras so that at the end, you end up with a really crisp and high resolution image, and that you couldn't do with a game engine because there are still limitations in game engine real-time rendering. But this is really, game engines are improving, so I don't know if this technology is really going just to die because game engines are going to be better. So at this point, this is really work in progress and demo stage. Even what Google showed was just a still image. It was, not video. There are new tests that they did. It's very heavy data manipulation, like 5 terabytes for 30 seconds. There is no standard, neither in the way the images are processed, it's all proprietary, or the file format. it's definitely 6 degrees of freedom, but there is still no direct interaction. And but this way, instead of just having an object or a person, like with photogrammetry and volumetric video, you can have like the entire scene, the entire environment around you, animated and moving, and that you can explore. So that was for what's coming from the CG world, I would say. And now from real-time production, it's kind of the opposite. Traditional production is not real-time, it's offline. We can spend months, making a movie or making visual effects for a movie. But they've been moving more and more into using the game techniques or even the game engines to do stuff real-time. So that's like the big buzzword in traditional visual effects now is real-time. So the first thing is the on-set virtual camera, which is the productions for the big budget movie has become so, like they have so much green screens that sometimes you just have the actors and green screens all over. So it's very difficult for the actors to act and for the director to direct the camera because they really don't know what they are going to be surrounded with. So they started to use, real-time camera tracking and CG render for Lord of the Rings and Avatar, but on Star Wars they did it with a much smaller technology, much more affordable. And if you look at it, let me make it bigger. It is a Steam VR controller that they are using. So they build this camera that the director can play with. Basically, it's an iPad with a Steam VR controller on it, a Vive controller on it, and he can play with it and use it as a virtual camera. And what he sees in the image is the frame that he's going to get once the movie is finished, or a preview of the frame. So it's much easier for a director to work this way than, to rely on a lot of intermediate steps with artists who set up the camera, and then he has to validate them, and then he has to ask for like modifications and stuff like that. So this makes things like much faster. The second step that is like more complicated is real-time compositing or real-time preview of compositing. When you have actors on green screen, like I was saying. So, for example, you can have the director look through, I have to remember where it was. So the director, you are capturing with the camera, you are capturing actors and a green screen, but the director is really looking at a composite of what's happening behind. I think that was here. Okay, well, I guess my Wi-Fi is kind of not working right now. No, let's leave it. Another example, for example, they did on Gravity, that they used what they call a light box. So instead of shooting the actors on green screen, they shoot them in an environment that was in an environment that was lighted the way it's supposed to be lighted in the final movie, so that the because it was very complicated what they did on gravity. So again, they were able to like real time move the camera, move the environment around the actor, and move the actor as well.
What we're trying to simulate is Ryan tumbling into the shuttle. We tilt Sandra backwards and forwards to help it. And at the same time, all the lights are spinning around in sync with this complicated motion.
I mean, it was literally like these rigs had your life in their hands. If something broke, I had nothing to hold on to. If some camera came crashing through my face, nothing I could do, you just say goodbye.
So this was like really the first time they were able to do something like that. They developed their own system to be able to do that, to both control the robots, the camera, the real-time rendering. So this is something that is becoming more and more common. And the last one you might have heard, you know, the Ready Player One, they also use this kind of technology to replace the actors on set by, you know, their avatars, so that the director is looking again at what looks like the final movie, even if it's, you know, still going to be reworked in post. And then there is this indie film that was made because they had a really low budget. They had to come up with new techniques of doing real-time compositing this time. So it's really like the final movie is shot in camera. And you know, it used to be like that before we had the computers. Like all the VFX, all the FX were in the camera, and Méliès started this way, and then. No, I'm fine. Yeah, that's fine. And then, of course, what is called a retro projection screen. So basically, you have the actor, you have the screen behind, and instead of being a green screen, you have a projector behind that projects the image, you know, back, and that's how they were able to like do the, you know, all the VFX live with the camera. So there is someone who did this now with a moving camera, because that works, you know, that kind of technique works for static cameras, being able to do those live CG render with no latency, so that you can have your final renders and record it with your actors, and you don't have to do any post-production. And
first, I had to figure out what else I was going to put there instead. The first idea was, why not just a photo backdrop? But the problem is they're flat. They don't move. My characters are dynamic, so for my film, the screen would have to adapt to a handheld camera's perspective. And I thought, what if we rendered all the angles bright enough, big enough, and fast enough that it would be seamless with the foreground? That's what I knew. I would need a team of people, artists, entrepreneurs, technical.
So when they finally figured it out,
system integrator were pulled feeling in the world.
Just yeah, here. So they show you first if it's just a flat
Huge
image.
amount of latency off of the screens to make it imperceptible to the human eye or to the camera, and nobody would do it until we met Matrix.
So I told the guys, you take care of your latency. Hammering at the whole global supply chain. We'll solve it on our end. Just be ready to test, because when those tiles land, it's not a lot of time to waste.
After
So
the
this
screen
is
came,
flat
I'll never
image.
forget the first night of
sorry.
testing when everything.
And then that's when they have the background render in real time with the camera tracking that mimics the same camera, and it just feels like it's 3D. It's there, but it's a rendered image that is projected on a screen. So that's what they were able to do. How do I get out of there? Okay. So I think sometimes it's really interesting to look at like outside of domain and field, because you know what it has been used for now, which is kind of simpler, is the mixed reality stuff, which is a flat video that is taken with the person being in VR, and then you have the real-time compositing of what's happening in VR behind this person. But you could imagine like a 360 video capture where, you know, your 360 video camera is fully tracked, your actor is on top of a green screen, and what you are projecting, you know, on a sphere, like it has to be a sphere, is a live CG render. You could, like, you know, do any kind of movie. So that's, you know, an interesting technique to think of. Not just to bring video into real time, but also to bring real-time CG into video. And then, of course, we have machine learning, which everyone is talking about. And what machine learning brings is we need to be able to recognize objects, to know that they are an object, to know what kind of objects they are, or what kind of person, or what kind of emotion, so that we can design interaction. Because right now, you know, even if we have video or objects that we can manipulate, if we want to do more intelligent kind of interactions or storytelling, we need more. We are not there yet. So that's kind of my view of where those new technologies are bringing us. There is more immersion. There is still not that much interactive, but it's coming there. It's moving. And in terms of conclusion, so we have an explosion of options right now for photorealistic, interactive, you know, storytelling and immersive storytelling. But of course, with that explosion of options comes an explosion of tools and pipeline, and it's getting more and more complex, and no one is going to be able to, you know, master all of those different tools. You start to, you know, to need specialists and even teams that are dedicated to that. But we still need to think of integrating all those tools, at least in terms of pipelines, even if, you know, there is not like one tool that's going to do everything. But you know, right now as creators, I find it extremely difficult that each company and each product is being developed as its own niche, and it's not being thought as, you know, how is it going to work with what comes before and what comes after. And in terms of format also and codec, everything needs to be invented. We are still with the 3D model or 2D video model, or, you know, it's still like not what VR needs. And then the last one is the metadata layer that I was talking about, to identify objects and characters and being able to interact with them, to have more interesting immersion and storytelling. So that's it. Wow.
We have time for a couple of questions. If anybody has any questions for Nathalie, please raise your hand.
Yeah, thank you for a great presentation. Do you have any examples of well-done volumetric productions? And then I'm curious what the time to create and implement is versus the end result. Do you have some sense of that?
Yeah, so I don't remember their name, but maybe someone remembers. There was a recent production that was done out of Australia that came out. It was a storytelling, what's their name? I will find it, but yeah, it came out recently. And there was also, I think in the ones that I mentioned, there was yeah, Giant was really well done also, and yeah, that's the one at the bottom here. And the whole environment that you see here is CG, and the actors are real and have been captured in 3D. You cannot like fully move around them, but it's been like really well done. I think, what do you mean like the time? Because yeah, it's going to take more time than a regular video, that's for sure, but it's going to take less time than doing a full 3D modeling of a person and rigging it and animating it and creating the textures and all of that. So it's an in-between, you know. But the time frame of you know, this production, I think it's not that much different from a regular visual effects. I mean, it might have been a couple months, but yeah, it's not something impossible, yeah.
Any other questions?
And some of the techniques that I've talked about, some of the presentations during the conference are going to talk about them. I just wanted to kind of give a framework and an overview.
Okay, I think that's it. Thank you, Nathalie. Thank you, Nathalie. Okay, we have time for 2 more presentations, and then we're going to take a break for lunch, and the marketplace will be open at lunch. For right now, we have